So what we have done till now, we have found out what are the fundamental forces acting, and then from that what we have found out, what are the forces acting on the battery pack. Then we have calculated the base plate loading. We used Kirchhoff equation for bending of a rectangular plate, and using the Rook's design data book, the analytical solution we have found out. It requires aspect ratio, and based on the aspect ratio, the two constants alpha and beta, which we found out, and then by using that we assumed what could be the maximum deflection, and based upon that we found out the thickness of the plate. Now once we have found out the thickness of the plate, then we have calculated other parameters, what could be the maximum allowable stress, and if that falls well within the yield strength or yield stress of the material, we will go ahead. If not, then we will do reiteration. We have done that. Then we started discussing about why battery swells, or how can we avoid that. So first we have to understand why it swells. That's what we have discussed, and then we have also said this can be mitigated using an end plate or providing a uniform pressure over, especially over pouch and prismatic cells. And then I think there is a question from Akash.
So what about cylindrical cells?
In cylindrical cells, by virtue of its, you see in the pressure every direction it comes same, it's a uniform in every direction on the cylindrical surface. In the pouch cells or in the prismatic cells, the stress or the pressure what you say is not uniform. Stiffness is more at the corners where you have joints. At the center point you don't have much stiffness, and that's why if you see here, because stiffness is more here in this edges, nothing has bulged out. However, at the center it's bulged out. The similar thing is for prismatic cells. Stiffness is more here, so it didn't bulge out here, but at the center stiffness is less, so it's bulged out. So the pressure is not uniform, and that is why it's happened. By virtue of its shape, cylindrical cells are most safe for this bulging phenomenon or swelling phenomenon. Okay. Once we understood how the cells or battery swells, then we need to find out how not to allow this thing to happen. Why it is important? Because a cell lives get degraded heavily because of that. A cell which can perform 1000 cycles, if this thing is happening, it may, if you allow it to happen, that cell may perform only 200 cycles or 300 cycles. That much degradation is possible in the cell life, or it happens in the cell life. How to avoid it? So to avoid it, what we need to do is to provide the uniform pressure over the cell surface. And how can we do that? By using the end plates, what we have shown in the battery pack. So how do we design the end plates? If we know what would be the cell pressure, I should constrain it. Then based upon that parameter, we can design the end plate by the similar equation what we have used for the base plate. So the pouch cells and prismatic cells are mounted with some pressure on its flat surfaces, and this is for avoid bulging or swelling, and that helps in enhance the battery life. If you remember, I have not talked about the cost much in this class, but the battery cost is a huge investment upfront, and when you do the huge investment upfront, you want to take out the most out of it, and you wanted to avoid all such things which can bring down your cell life or battery pack life, and it's one of the important parameter which brings down the cell life drastically or your pack life drastically. To avoid this, we provide the end plates which can maintain a uniform pressure over the cell surfaces so that it should not bulge out. Cylindrical cells generally do not bulge because of its shapes. Now, the value of this optimal pressure, from here we will find out. Mostly the cell manufacturer will give you upfront that my cell should be constant within this pressure. If they are not giving you, you can also do experiment in the lab, very simple experiment. You provide the two plates, constrain the cell, provide the pressure transducer on the surfaces and do charge and discharge cycle multiple times, and from that you will find out what would be the cell life, and that you have to repeat multiple times for the different pressure value. So from that you will find out what would be the optimum pressure on which the cells gives me the most of its life. Otherwise, get this information from the manufacturer, because manufacturer has already done this. Now, once you have that value, then you start designing the end plate. So, for a specific prismatic cells, that optimal range lies between 4 to 18 psi. A pressure in between that 14 psi, what we have used for the calculation purpose, and the psi to Pascal conversion is given here. psi to Pascal conversion is provided here. The right side, there is a graph. What it says, if you put 1 psi pressure, uniform pressure, your cycle life would be around 100. If you put 6 psi pressure, then your cycle life would be 1400. If you provide 5 psi pressure, your cycle life would be 1900. You can see how much difference in the cycle life of a cell is there just on the pressure, uniform pressure provided over the cell surface. So it becomes one of the most important parameters designing any battery pack using prismatic or pouch cell. And this is what will give you the most of the cell life from your upfront capital cost. 1900, 100. Basically, what you are saying that I'm literally not putting, I'm allowing the cell to swell. Here, you are providing an optimum pressure that comes between 4 to 18 psi to get the maximum of this. However, this is impossible to maintain always the same pressure. It will vary depending upon the cell expansion and contraction. So, somewhere in this range 3 to 6 bar, you see you get from 1300 to 1900, not 100. This is a question of unconstrained cell. However, a constrained cell for a uniform pressure, you can get something between 1300 to 1900 cycles. What are the other battery pack design consideration? For thermal management, we will discuss more it in thermal management also. In case of thermal runaway, what happens? High temperature gases and effluent are emitted from the cell. Now, if your battery pack, if you don't allow these gases to escape, your battery pack will fail at the weakest point. And you don't know where is the weakest point. It's very difficult to find out the weakest point of a full system. To avoid that, and if it comes out from any places, then you have a passenger, you have a vehicle that will get affected. And generally these gases are combustible gases. It can ignite, can get fire. So to maintain that only at this particular place the vent should happen, you can provide a pressure relief valve. And that you have to design upfront. What pressure relief valve, what would be the pressure, where would be the location. And that helps in mitigating thermal runaway also, because you are throwing out the combustible gases at controlled manner. This also helps in preserving the battery pack shape and the strength. It also helps safety risk of passenger or any other vehicle component. So what care has to be taken? The care has to be taken by controlling the direction of release of the hot gases or hot fumes, by restricting the thermal interaction between two cells or between two components. And you can have one pressure relief valve or multiple pressure relief valve, depending upon the size, capacity and requirement of that particular. And one of the design in mechanical design of packaging of battery packs for electric vehicle, they shows where should be the gas exhaust. At multiple places they have put, in this only are the two places they have put, so that it does not impact the vehicle or passenger much. And these are the extreme cases. These are the rare events, these are the extreme cases, but you have to be prepared for that, so that you need to implement the things into the design itself. And obviously it's a part of mechanical design. What would be the pressure, what would be the, you don't want to keep it open always. Only the pressure limits exceed, then that valve should get opened up. The other design criteria, what I have asked, what we have discussed till now, what we have taken only the self weight of battery for designing a base plate. But there could be many forces, many other forces. There would be many impulsive forces also sometime. Like if your vehicle has suddenly gone in a patch hole, that force is impulsive force. If your vehicle is toppled, still you don't want your battery pack to get affected. Because if that happens, it can catch a fire, and the vehicle as well as the passenger both would be at risk. So one of the important things is that maintaining pressure in prismatic and pouch cells, then crash protection, vibration isolation. If vehicle is vibrating, that should not get transmitted to the battery directly. You need to isolate in between that, so that that vibration should not reach to the battery pack. What care has to be taken? So you need to design different loading plates properly, like base plate, end plates, side strips. Then you also have to provide crumpled zone, so that in the case of crash or in the case of shock, that region absorb all the energy and it should not reach to the battery to its failure extent. You need to provide different vibration damping solution there. It could be a pad, it could be a vibration isolator, so that the any vibration which is coming in the vehicle body should not get directly transmitted to the battery. At least it should be damped out to the limit of the battery pack vibration. So with that, we'll start something new. Our second part, what we have done right till now is we have discussed all about the regular force, regular design. The another important aspect of a mechanical design is vibration. And that's what we'll start now with the vibration in the battery pack. Okay? What would be the impact of vibration and shock? Before finding out the impact of the vibration and shock, we need to find out what are the sources of vibration. Am I right? Unless you don't find out a problem, how can you solve it? So first you have to find out what are the sources of vibration. The sources of vibration, the first things comes the motor and drivetrain, because it has a lot of moving parts. It's continuously moving. The second important source of vibration is the road roughness. It could have a patch hole, or even in the regular road, there would be a lot of waves and irregularities. It is not perfectly plain. In motor and drivetrain, it depends mostly on the motor speed. Is there any imbalance? Various loading patterns. Because of that also it happens. Road roughness is an important factor because of the road itself. Then there is a tire imbalance. If tire is not balanced properly, it will start generating the vibration. What happens? After some time, even a perfect tire wear out unevenly. When it wear out unevenly, that comes as a dimensional vibration. We know about everything motor, so it comes into the harmonic vibration because it's a sinusoidal. The RPMs, we know how it gets generated. The random vibration, we don't know how it gets generated. We don't have any profile for road. Even if we try to make the road load data, it's basically a statistical analysis. We try to fit it into the average, mean square values. We try to fit through a statistical analysis, but there is no regular profile. Tire imbalance or tire dimensional changes does not have any regular pattern. In one vehicle, this can happen slightly different. In another vehicle, it can. So again, we do a statistical analysis and we try to find out. We try to see a pattern. Then there comes shocks or crash. What we know very well is crash. Shock we don't know, but it's both are same. A small time scale, very huge amount of force. Because of that small time interval, huge amount of force, there will be very high acceleration, huge acceleration. When I say acceleration, it could be acceleration or deceleration, both. It can lead to the thermal mismanagement, can. And if it leads to thermal mismanagement, when I say thermal mismanagement, because of the chemical, if the forces is going to applied on the batteries, all cells, it can get punctured, it can have internal short circuits. And because of that, as soon as you see word short circuit or a chemical reaction, the huge amount of heat get generated, which cannot be controlled using the regular thermal management system. And if such things happen and you have not designed it properly, it can explode. The battery pack can explode. Especially the situation like this, you see one vehicle head-on collision with another stationary vehicle. So everything has, you see, has come into the pieces. And what I was saying, it's a very small time scale, and because of that, huge acceleration, and that is responsible for huge transmission of energy. So when we are talking about crumpling zone, that means this energy should not get directly transferred to the battery pack, and that's a part of our vibration and shock design. What are the effects of the vibration on a battery pack? What can happen? Because of the vibration of the vibration on a battery pack, several things can happen. The first one is welding failures. The spot weld between cell taps and bus bar, and this spot weld can be done either through laser or through resistance welding or even through ultrasonic. If it breaks out, then there is a chance of high contact resistance. Or if I have a multiple spot weld and some of them has failed, I have now more contact resistance. What happens because of more contact resistance? The more heat will get produced there. And if more heat will get produced there, what will happen? Your part locally start melting. More heat means more temperature. When we say more temperature, that means the part locally start getting melted. Ultimately, the whole pack will fail. Because of vibration, if your thread design is not proper, the fasteners which is connecting the multiple bus bars together or which is connecting the packs will start losing up. When let's take example of bus bar. If we start losing up, what will happen? The contact area will start reducing. Finally, what will happen? Again, your contact resistance is getting up. Now your contact resistance is getting up. What will happen? Temperature will start increasing. As soon as temperature start increasing, it start expanding, and your nut start getting loosened further. Ultimately, it will fail. If resonance frequencies, component resonance frequency matches with the excitation, either by random or a deterministic, like suppose the motor resonance and the part resonance is same, what will happen? What happens in resonance? The deflection becomes maximum, and if that deflection, the maximum deflection is not designed for, it will fail. And in resonance, it's difficult to design for a resonance in the sense that maximum deflection. The maximum deflection is supposed to be infinite, so it will break out. So we always try to avoid the resonance frequencies. We always try to shift the resonance frequency beyond the operating range of the frequency. Electronic components failures. You have several electronic components inside the battery pack: BMS, thermal management system, high voltage isolation system. If some of the components fails because of the vibration, what will happen? Your functionality will reduce, or gradually the whole battery pack can go to unsafe mode. The plastic parts or even metal parts or any other parts which you are using for insulation, either thermal or electrical, may start cracking. When it start cracking, what will happen? You may have a voltage leakage, and that could lead to EMC, EMI noise, and that is not a good thing, because your battery pack will fail or nearby component will start failing. So these all are the effects of a vibration on a battery pack. Because of the cell failure, because of the weld failure, your contact resistance is increasing. Your contact resistance is increasing, that means you are wasting a lot of energy in the heat. So your capacity of the battery pack will reduce ultimately. And this all happens because of the vibration. What are the tests we do on the battery packs? Vibration test or vibration simulations. So in India, we mostly follow AIS 048 and AIS 156. For shock abuse, again these two parameters. For random vibration test, which is not part of Indian standard, but yes, one can follow SAE J2380. And this is how a vibration machine looks like. And this is the battery pack, vibration table, and that exciting mechanism which excites this table, and that finally excites this battery pack. So what we do basically, we fasten the battery pack on the vibration table on the setup, then excitation is provided by this machine, and depending upon the orientation of the battery pack, it's a pack laterally along the horizontal plane of the table, and if we have to do perpendicular, we turn either the table by 90 degree or we turn the battery pack by 90 degree. And in the third axis, we change the direction of the battery pack. So we do one horizontal and the two parallels one by one, not all the three things done together for the testing. However, in actual cases, you may find all the three directions together. So the two test standards what is followed in India for the smaller vehicle, AIS 048 and AIS 156. For AIS 048, it's a 3G, 30G. You can download this, available on homologation agency like ARI, ICAT, GRC. You can download these two standards and can have a nice look on what are the things get changes. So for acceleration in harmonic test 3G, for shock test is 30G. Here it is defined based upon the weight of the pack, and a drop test get added up in the AIS 156. Here for the shock test, only the two direction along vertical and horizontal. In AIS 156, it's along all three direction, and more or less, except some small change in frequency range, both are same. This is the actual testing, how a battery pack is being tested. This is vertical axis and this is the horizontal axis. A nice YouTube video is here. You can watch the full videos of the testing of. Here it is with cylindrical cells. There are small multiple packs together. So any question till now?